Okay, so here you go. Just repeating what I said before, right? There is this concept of electric charge. And we have either negative charges, positive charges, or neutral charges. There are three particles that you should be aware of, something like that you study in chemistry. We have the electrons, the proton, and the neutron. The electrons are negative, the proton are positive, the neutrons are zero charge. So the proton can attract the electron, but the proton do not attract the neutron. And electrons do not attract the neutron either, via electrostatic force. The electric charge, the unit of electric charge is the coulomb, abbreviated, let's see, abbreviated by the letter C, okay? C for coulomb. And the charge of the electron is this value here, but that's the charge of the proton as well. The electron is a negative of this value here. What you have to know about this number, you don't have to memorize it. Sometimes it's difficult to memorize those numbers. You don't have to memorize, but you have to know a very important thing. That's the lowest electric charge that you're going to find in nature, okay? That's the lowest electric charge. You're not going to find an electric charge that's 0.8 times 10 to minus 19 coulombs. You're not going to find anything like that. And there is one other important piece of knowledge. You're not going to find electric charges that are 1.7 times 10 to minus 19. You don't find that either. What you do find is that the electric charges are equal to an integer number of this value, okay? We say that charges are quantized. That's what we say. Quantization of charges. And that was demonstrated in a very smart experiment. If you know what this example is all about, if you know the net charge of a given object, you can estimate the number of electrons or protons that object has. That's what this example is all about. How many electrons are there in 1 coulomb of negative charge? Suppose that you have an object that's charged at 1 coulomb, minus 1 coulomb. How many electrons? How many excess? The best way to ask this question, not how many electrons are there, but how many excess electrons are there in 1 coulomb? Okay, that would be the correct way of asking this question here. Okay, how many excess electrons? Because we still have electrons in addition to those excess electrons, which is 6.25 times 10 to 18. Okay, and then we have the electric force that I mentioned to you. There is an equation for that. Here you go, like charges attract, like charges repel, right? Opposite attract. And what is the equation for that? Let me show you the equation for that. Because the equation for the force, we can quantify the force is going to be the value of charge number, the force between two charges, right? That's what it is. The force, here you go, the force between two charges is, the value of charge number 1, the value of the charge number 2 divided by the distance squared. And we still have a number here, is a constant, universal constant, that has this value here, has been measured in the laboratory. You don't have to memorize this number again, but you must know that there is this constant here. Note, see that the further the charges are apart, the weaker the force is, right? Okay, so let's write that down here. The further the charges are apart, the weaker the electrostatic force is. Electrostatic force is. Okay. Also, the higher the value of the charges, Q1 and Q2, the larger their force. Okay. The larger the force between them. The force between them. That's what I covered last time. So that's a brief summary of what we did. What I want to do now is to go through the syllabus again. Okay, to cover you how you're going to do the lab, right? Most of you already know that. Online lab activities, okay, laboratory work. So laboratory work is an important component of any science. The ideal way of doing those experiments is in the actual lab, is hands-on experiments, okay? So you learn far more when you do that. So the idea of the lab is to reinforce the concepts presented during the lectures, demonstrate in practice the concepts taught, familiarize the students with various types of equipment available for engineering and research purposes, okay? So during those labs, I expose the students to important equipment that I sold out there, and we oftentimes we do need them in our day-to-day life to see, for instance, if a battery that we are using is charged or not, okay? If a battery that we are using needs to be disposed or not. That's there are instruments for that, and they're not expensive. You can find equipment that out there to make this type of measurement for $15. Demonstrate lab procedures and methods of data analysis. In this lab that we're going to do, the virtual lab, we are going to emphasize mostly the methods of data analysis, because we're going to be using Excel. We're going to analyze data that I'm going to provide to you, and so on, okay? In a real lab, we also learn techniques to troubleshoot an experiment. Very important skill, troubleshooting something at home. You're trying, for instance, you're trying to turn on a light bulb, the light bulb doesn't turn on. What's happening? The light bulb burned out, or it is something else, or the light bulb is good and it is something else in your circuit there at home that's not turning on the light bulb, okay? That's what troubleshooting is all about, discovering what's wrong with your experiment. In our experiments, I call them make-believe experiments. You'll be working with no more than 3 classmates. We do have groups with 4 classmates, right? You can choose your classmates. However, the instructor has reserved the right to change the members of your group. Some of the students chose their own classmates because they knew the classmates, and because they worked with them in the past, they know they work well. But some other students are new here, don't know anybody, so I had to help them out and fit them into a group, right? Materials for the lab, physics lab manual. Yeah, I have, it's not required, okay, but it's recommended if you want to learn a little bit more. The lab manual is my own lab manual that I put a reference there for you, right? Let me see, did I put there? Zoom link, oh yeah, I did, okay. Yeah, that's the one. All the experiments are taken from my lab manual, but you can perform the experiments without this lab manual. Let's see here. Okay. Physics bound notebook. Remember, I told you about my bound notebook that I'm very proud of. I always putting my notes here in my bound notebook. When I'm performing experiments, I jot down some notes in there. Sometimes I have an idea in my head. I also work the idea out in my bound notebook. Sometimes I come up with a new invention, like it fairly frequently happens. I register my invention in the book before patenting it. So I want you to get familiar with a bound notebook. You can also use the computer, but sometimes, like Microsoft Word, you can also use Microsoft Word, but sometimes it's good to have this bound notebook to complement the work that you're doing in front of the computer. And the bound notebook has another advantage over the computer. The bound notebook can serve as a legal document in the courtroom. Okay, a document that you easily edit in the computer is not as strong as evidence in the courtroom as a bound notebook. Okay, if I am a scientist and I want to claim priority over an invention, I log my invention in my bound notebook. If someone questioned that invention, oh, I have my bound notebook here that I discovered such and such thing in such and such a date. Okay, it's far more. This is a legal document compared to Microsoft Word file. Reliable internet connection, right? Pen flash drive, or access to the cloud, to store your data. Just like that folder that I opened for you in Google Drive, right? So you're going to come up with a lab report. The lab report, you're going to perform an experiment, the experimental activity, the virtual experimental activity next week. And then what you're going to do, you're going to come up with a lab report. The lab report consists of 2 documents, a hard copy, which is a document in Word format. Let me give you an example. My students already know about that. Okay, so I'm going to give an example from last semester. Okay, so here we go. Fall. I have a sample. Let's see here. Lab reports. This must be here. Nope. Quizzes. Well, I'm going to. Is that the one? Oh yeah, here you go. Here's an example of the so-called hard copy. It's not exactly a hard copy because it's the electronic document, right? So you go ahead. You're gonna need a hard copy, but before we get to the hard copy, let's talk about the spreadsheet. I'm gonna change orders here because the spreadsheet comes before the hard copy. Okay, a spreadsheet, a report in Excel format, and a hard copy, which is a file in Microsoft Word. In my Microsoft Word format. I call it a hard copy between quotes because nobody will print this document. Instead, right, you upload your electronic file to your group folder. Let me give you an example of the spreadsheet in case you're not familiar with that. Raw data labs. Okay. Raw data. Okay, here's an example of one of the spreadsheets that I used in Physics 6. The spreadsheet of Physics 7 is not going to be much different. Okay, here you go. I have spreadsheets for all the groups here in the classroom. Okay, I pre-prepared the spreadsheet for you. And let's get the spreadsheet here for lab number 2. So this spreadsheet is going to have pre-prepared tables. Works very well. Okay, I've been doing that for several years. With data for you. Okay, I prepared the data for my students. And that's what's going to be your first part of your report. A spreadsheet that you're going to fill up, the units, okay, of your measurements that are here. Okay, in this case, you have a length of a cart that should be a unit of meter. You have a length between 2 points in a track that's going to be supposed to be meters as well, and so on. Okay. So what you have to do, you have to fill up the units of all those quantities. First thing, very important. And you also have to display your measurements with the proper number of significant figures as well. Okay. In this case, the numbers are already displayed with significant figures. But in this case here, they are not. depending on the experiment that we do, I will tell you, what's going to be the resolution of your measurement, and then you will have to display that measurement with the proper number of significant figures. Here is a measurement, a time measurement in seconds. Here is a position of your cart in the track. You're also supposed to display that's the proper number of significant figures, okay? And you have to fill this table as well with the confidence level. And I'm going to upload that as well, the confidence level table. One of the things that we do, here you go, and you also have to plot a graph. In this specific case, okay, what you're required to do was to plot a graph of V squared against D, okay? That's what you're supposed to do in this specific experiment. I'm going to walk you through. In case you do not know how to plot graphs, you will need to learn how to do that. And I spelled that out in my syllabus as well. Okay, so here you go. Lab notes, here you go, this one. Spreadsheet, that's the spreadsheet. This spreadsheet is going to have a graph. I'm going to plot the graph. You go to insert, chart, scatter plot, and see we get a pretty good straight line there, with the exception of this one that is kind of an outlier. Okay. So that's the spreadsheet that you have to turn in. Once you have done everything that you're supposed to do, then you're going to create that hard copy report that I mentioned, the Word document. Okay, and I have one sample here of this Word document right here. Okay, how's the format of this Word document? You're going to write it down, physics lab report. In this case, it's going to be physics 7. Right? Let me save that elsewhere, and I'm going to change the name of this one. For our first lab, is going to be lab number 01. The name of the file is both the spreadsheet and the Word document will always have this format here, P07, right? That's physics 7. Lab number, in this case, the first experiment is going to be L01, and your group number, 2-digit group number, 01, 02, 03, so on. I put XX in there. Okay, and let me save this one right here. Lab reports. Save. The format for this document is spelled out in the syllabus. Okay, let's go back to the syllabus. Syllabus right in here. Each group will submit a single lab report, a spreadsheet, and a hard copy. I don't need to stand here. I'm going to save it as a number 5 version. It has minor modifications there. Okay. So the Word plus the Excel document with a spreadsheet with your actual data. The spreadsheet contains the data and the results required to plot graphs, if any, of the virtual experiment. The Word file is a document in the proper sense of a report. Okay, these 2 documents must be turned in the date announced by the instructor. Is usually before the beginning of the next experiment. The instructor will provide you with the Excel spreadsheet with your data. I will provide you with that. So you don't have to worry. You don't have to generate data. This spreadsheet will be placed in the group folder, by the way. Okay, that's why I come up with your group folder there in Google. I still didn't figure out how to do that in Canvas. So I'm still using Google. If you know how to do that in Canvas, let me know. I'll be happy. Okay. All group members must contribute to the preparation of the lab report. to ensure the contribution of every group member, I advise that each group draft a simple agreement in writing, committing each of their members to contribute to the write-up of the final lab report. This agreement should specify the contribution of each group member. Okay, your lab report is worth 100 points, and your grade will be based on the following. Every measurement and result, not just measurement, every measurement and result must be reported in terms of the main SI, International System of Units, meter, kilogram, second, Kelvin, and Coulomb. We just learned about Coulomb. In the case we have experiments that deal with small, right? I'm gonna boldface that because we just covered coulombs and candela. There won't be any experiment with candela here. And every possible combination of them. You will not report their units in centimeters, millimeters, grams, milligrams, hour, minute, etc. The correct number of significance figures. Okay, already. The way I do significance figures, I use only the resolution of the measurement. Okay, some instructors go further away. They use the next figure as a significant figure. I prefer to use, there's nothing wrong about doing either way, but I prefer to use the resolution of the experiment because it's a more conservative way of reporting a measurement. For each missing significant figure, I will subtract 0.1, 0.2 to 1 point from your lab report grade. On the other hand, for each significant figure that added incorrectly, I will subtract 0.1 to 0.5 points from your grade. The exact number of points to subtract will depend on the lab report. It varies from lab report to lab report, okay? But it's gonna be anywhere between that. What else? I have measurement. I didn't write that down here, right? Yeah, I should write that down here. Let's see if I did that further down. Okay, I should tell you here for every missing or incorrect unit, I will subtract 1. I will subtract 1, 2, 3 points from your report. Okay. So now we have okay, because the proper units okay, we don't need that. Proper format, there is more below. Neatness, completeness, and accuracy of your results. Reporting of proper statistical results, such as average, standard deviation, percentage difference, standard deviation from the mean, regression curve, determination coefficient, correlation coefficient, confidence level, and others. Okay. You know, all those things can be calculated by Excel itself. If you learn how to use Excel, you know, you can find the average using Excel, the standard deviation, the percentage difference. You have to type the proper formula. Standard deviation from the mean, the regression curve, Excel can calculate that for you when you plot a graph, right? The determination coefficient, you already know that Excel calculate that for you. The correlation coefficient as well as the confidence level, you're going to get from a table that I will provide to you. For each incorrect value, I will subtract 1 to 5 points in this category. Graphs, right? Let's go to the graphs again. Let's practice how to plot graphs. I'm going to get my students should already know how to do that, right? And so maybe some of you that are new do not know. What I'm going to do here, I'm going to plot X versus Y, okay? Y versus X. In my spreadsheets, okay, I usually put the units in a different cell here in Excel. X, if it's a measurement, if it's a length, I should put it in meters. Y should be put in meters as well, if it's a length. And let's do the simplest graph that we can plot. Okay, is a linear graph with numbers. Suppose those are measurements, right? 4, 5. I usually get 6 data points in my graph. If those data was measured with a ruler, this data were measured with a ruler, I should format them with the proper number of significant figures. My ruler has a resolution of 1 millimeter. Most rulers out there do. So I have to report my measurement up to the 3rd decimal place, where the millimeter goes. Okay, that's how we report the measurement. That's the right way of reporting the measurements with the right number of significant digits. Measurements measured with a ruler. Now I'm going to come up with other values as well. So let's say I'm measuring. I have a bunch of. Let's say I have a bunch of squares, right? And I am measuring one side of the square and the other side of the square. It looks like it's a square, right? In the horizontal direction is my x, the vertical direction is my y, and I still got, because it's a square, I also get 1, 2, 3, 4, and 5, right? When I plot those values, what you have to do, you have to highlight those numbers, insert, and graph it, right? Here you go. That's how you plot a graph in Excel. Is a perfect straight line. You're rarely gonna get something like that in the lab. A perfect straight line. Okay. I'm gonna show you exactly what most likely you're gonna get in the lab. What else do we need to do? You have, let's go back here to my syllabus. Here you go. The graphs must be clean and planned to optimize its space. No large blank areas in the graph. Okay. So is it optimized or not? It looks like it's optimized, right? There's no large blank spaces here. What do I mean? I don't want a large blank space. I don't want anything like that. Let's see, -10. Let's see. I'm changing you should never plot a graph like that. Okay, with this large blank space right in here. Okay, so you must optimize your graph. Okay, and I will determine the grade of your graph with respect to the percentage of the area in your plot. For instance, if you use only 10% of the total area of the graph, you get only 10% of the points allocated for the graph. Okay. However, if you plan your graph in such a way that you use almost 100% of this area, you get the full allocated points. Okay. Let me give you another example with different numbers. Right. Let's see, now we have a different type of. Now we have a rectangle, not just. I'm going to put y prime here. That's meter. And then instead of, if it's a rectangle, it shouldn't have a 0 there, right? Let me take out the 0 from here. Yeah, here you go. And I'm going to put another number. I always like at least 6 data points in my graph. Now, suppose I get a rectangle. The vertical plot is going to, in my rectangle, is going to be twice 4, 6. No, I don't want to do that. Let's see. No, I'm going to do more than that. It's going to be a rectangle that's 4, 8, 12, 16, 20, 24, right? Now here we have a square. I provided you with 6 different squares. You're measuring the size of those 6 different squares. In the horizontal direction, you have those values. In the vertical direction of your square, you have those values. Now I provide you with a bunch of rectangles that you're going to measure in the horizontal direction, in the vertical direction. Let's not forget to put the proper number of significant digits, right? 3 decimal places because you're using a regular ruler. There you go. We need one more point. This graph looks good. We do not have large blank spaces in the case of this graph, but let's take a look at this one here. The graph for the rectangle. All right, so here you go. I need something better than that. I didn't choose the numbers properly. Let's put it here. Let's see, maybe this one's 6. Yeah, let's do this way. Better this way. And 12, 14. Yeah, better. Okay. Let's say those rectangles has those dimensions here in the vertical direction. Notice that we're starting to have a big blank space here. Okay. So when you have something like that, you're required to choose the proper units here in the graph. And it is okay to start your measurement at 2, for instance. Now this graph looks better. See that? You don't have to start at 0 all the time. You can start at non-zero number. Okay. I have seen students who has plotted the graphs with very large blank spaces. I don't want you to do that. Okay. That's what that part is all about. 10:54. We're almost due for our break, right? Graph. Okay, you must label the axes of the graph with their proper quantities and their corresponding units between parentheses, right? So let's label the graphs, the axis of the graph. You click the graph. Let's start with this one. Okay. And do you notice? I'm going to unclick the graph and watch what happened here at the top of Excel. Unclick the graph. Do you see all those 2 options? They disappear, right? But when I click the graph back, those 2 options shows up. I can either click on chart design or I can click on format. If you want to put the labels in the axis, you have to click on chart design. And then you go here to this add chart element. Okay. When you click on add chart element, you can put the title of the axis. You go here on the option axis title. Notice that we have a primary horizontal and a primary vertical, right? So I want you to put both of them in there. Primary horizontal and primary vertical. And write down here what it's all about. It's going to be the measurement in the vertical direction, y, with a unit in meters. Here too, a measurement in the horizontal direction that I call x, and the unit between parentheses, meter. Okay, that's what this. Any questions so far? That's what this item B means. Ensure that the numbers along the axis are properly spaced and not encroaching on each other so they can be read properly. What do I mean about that? Okay, those numbers looks pretty good, right? They're not encroaching on one another, right? But I have seen graphs in which a student put those numbers so close to each other that it's very difficult to find out where this number starts and where the number ends. You do not want anything like that. Okay, you have to choose a proper major unit here. In this case, should be 1. Looks good. It's okay if you choose 2. You're going to start to have a problem, right? You're going to start to create a very large space here, right? So there's no need for you to put a unit of 2. You can go back to 1. And even better, you do not need to have all those decimal places here in your graph. Okay, you can remove those decimal places too. You don't need to put significant figures in the axis of your graph. And there are ways to do that as well. You can go here in this format axis table, right? Click on numbers, and you have the decimal place option here. I can put 0 decimal place and look what happens. Now I have the numbers there. You can do the same right here. I double click the axis, the numbers in the axis, put 0 decimal places, right? What I usually like to do, I like to boldface those axis title to stand out. And I also like to boldface those numbers. You don't have to, but makes those numbers stand out, okay? And you can even make them larger as well. That's what we have for that item. Do not connect each data point with straight lines, okay? Excel allows you to connect each data point with lines. Let me see, chart design, let me see. Let me replot this graph so you can see what I mean. Excel allows you to do that. See, we have this scatter plot. You have no lines between the data points, you know, lines with the data points and straight lines with the data points, right? No data point, no data point. Don't do that. Don't do that in your graph, okay? Always plot the data points, always. Always plot the data points. That's what I mean in that item. Do not connect the data points with straight lines. Instead, fit the best average curve to this data. Okay, so let's do that together. It's a very, it's amazing what we can do with Excel. Okay, so here you go. How do we do that? Okay, we're going to use the trend line function of Excel, and everything is documented here in my syllabus. Okay, click one of the data points. When you click one of the data points, all the data points are highlighted. Okay, and this little thing shows up as well. So notice that the points that I plotted are also highlighted here in Excel, right? What you do next? Right click on one of the data points and highlight add trend line. Okay, now you have a proper line connecting those points. Okay, you have all sorts of options of trend lines. Most of the time in this course, you're going to use linear trend line, the one that shows the most. And then what else do we need to do? We're going to display equation chart. You're going to display R-square value on chart. Don't set intercept, okay? Don't set the intercept value. And here you go. Excel calculate the equation for those data points, okay? That's how you plot your graph. Do you have anything else? 11 o'clock. You go right click, select, okay, click OK. Checking the box to display the regression equation. Okay, so that's how you plot graphs in Excel. Let me show you what real life data looks like, okay? This is not real life data. This one I'm just making up. It's an equation that is exact, it has an exact mathematical behavior, y equal to x. But in real life, you do not get exactly 1.0. You get something like 0.9, you know. Let's say you get 2.1. That's what you get for your measurements. You get, let's say, if you have you can even get 3.2, okay? And so on, okay? Here's going to be 3.95. That's the nature of measurements. You never get an exact measurement, whenever you're performing an experiment. If you do get an exact measurement like you got in that graph before, you know, you either are cheating, okay? You either made a mistake, or very rarely, you discover something new that nobody knows. Or there's another option too. There are four, right? First, you could have made a mistake. That's possible if you get an exact R squared equal to 1. Okay, you either made a mistake, you might be cheating, you discover something new, or you are using instruments that don't have enough resolution. For possible reasons for getting that R square equal to 1, the exact R square. Now look what happens in real life data. Okay, previously we had an equation that was y equal to 1, right? But now it's not y equal to 1, but it's close enough. It's 2% off. The slope is 2% off, and we have this intercept here. That's still small. The R squared is no longer 1. The R squared is less than 1. If I look at this data and look at the previous one that we saw with R squared equal to 1, I'm going to believe this one, not the other. Okay. So 1103. And attendance and participation to the online lab session accounts for 20% of your lab grade, whereas the remaining 80% comes from the correction of your lab report. Consequently, if you are present during the online meeting but fail to turn in a report, your grade will be 20%. However, if you fail to attend an online meeting, your grade will gonna be 0, okay, for that specific meeting. Also, if you turn in your hard copy report but fail to turn in your spreadsheet, you get no more than 50% in your grade. The same applies if you turn your spreadsheet but do not turn your hard copy. Both the hard copy, the Word file in electronic format, not a Word file, the Word file and the spreadsheet, the Excel file, must be uploaded to your group folder, a link of which has already been provided by your instructor, right? Already provided you with the link for your group folder. 1104, let's take a little break now. Any questions about that? My students already know about it, right? And because they made lots of graphs already. Let me see, Lebilud, are you there? Hello, Lebilud. Let me see, I want to, let's see here. Yeah, I see her here, but she's not answering. I will, here we go, give her a step. Oh, I already gave her attendance here. Good. Okay, so any questions? I want to give you another opportunity to ask a question. Let's take our break right now, another 15 minutes break, and we finish this document here. And if we have time, I continue lecturing on the material, on the material of chapter 18. Okay, but before we go, let's see, lab notes. Here you go. And break from 11:05 to 11:20 a.m. Okay, so see you in 15 minutes. here. Recording again. Good. So here we go. We are done with this part. The R value is referred as the correlation coefficient, and it's square the determination coefficient. Okay, that R value that you saw is the correlation coefficient. But Microsoft Excel displays only the square value. That displays only the determination coefficient. This value has a specific and useful statistical meaning that we'll be discussing in this course. Okay, and you already saw, right? What R is all about. This R here that you see is a measure of how close your equation is to the actual data points, right?
Excuse me, Professor?
Oh, yeah, I need to share the screen, right? Thank you.
Yes, thank you.
Okay, thank you for reminding me. Now let's see, the C here gotta be moved. Okay, so where were we? Right here, right? No, we are looking at the syllabus. Here you go. The R values is referred as the correlation coefficient, right? And it's square as the determination coefficient. This value has a very specific and useful statistical meaning that we'll be discussing in this course. But you should have already noticed it, that the closer your R is to 1, or R squared is to 1, the more perfect the fitting you have for this equation. Okay, that's what this R value, that's what the interpretation of this R value is. It has to do with how close the equation, the mathematical equation that you derived, is to your real life data. Okay, here's your model, and those data points is your real life experiment. Okay, we are trying to figure out what's a good mathematical model for this data, for this experiment, the experiment that you're seeing here. If you had exactly the same values that we used to have before, right? 1, 2, 3, 4, 5, 6, you can see that correlation is 100%. R squared is equal to 1. But like I mentioned before, you know, you're rarely going to get anything like that. 100% correlation, 100% fitting between the mathematical model and your data points. So you most likely you're going to get something like that. Okay, it's there will be a total of 8 to 10 lab activities. Each activity we have their respective lab reports, right? The due date of lab reports will be announced. As a general rule, each lab report is due before the start of the next lab meeting. All lab reports will be group reports. At the end of the semester, I'll drop the lowest grade of the reports and determine the average grades from the remaining ones. The last lab report will be due at the end of the last lab meeting. Oh yeah, the last lab report will be due at the end of the last lab meeting. Okay, the last lab report is the only exception here because we do not have a next lab meeting, right? So I asked you to work just the spreadsheet, not the Word document for the last report. Lab report format, you're okay. The hard copy that I was doing there for you, right? Your lab report must be prepared in Microsoft. Let's see, the hard copy of your lab report must be prepared in Microsoft Word and uploaded to your group folder. I recommend you to use Times New Roman. You use Times New Roman font or similar, size 12 or larger, not smaller, and departure from the document format will affect your final grade. The required information must appear in the following order. So let's go now to our hard copy report, right here. And let's try to do a template for our first lab. Physics 7, physics lab report, physics 7. And then next line, lab 1, you put the title for the lab, electric field 1. That's going to be the first lab report. Then you put the names of the students in alphabetical order by family name, okay? Family name, first name, family name. First name is student 1, right? Family name, first name of student 2. One name per line, okay? Please do one name per line so it's easy to check. It's easy to read each student name. Here you go. Student number 1, 2, 3, and 4. Group number X. There is one more piece of information. Go. Let's see if I put it here. Physics lab. Okay. Date of performance of the experiment. Something like that is missing. Okay. Date of the performance of the activity, right? Which is going to happen on February 15, 23. Remember, it's the date that we did the activity, not the date that you turn in the report. I'm gonna emphasize it here. Of performance of it is the date. It is the date we met to perform this virtual experiment, and not the date when you turn in the reports, right? The report. In the next page, prepare tables, the original data, and any results. Okay. Next page. Here you go. I have a table here. You know, you're going to see tables like that in the. Let me see if I can get the table for the next experiment, so you can have an idea, a better idea what you're going to see next time. Physics 37, raw data, fall, lab reports, no, that's physics 37, let's see, fall, should be spring, lab reports, see those physics 38, no, not here, must be here, physics 38. Hard copy, must be this one. Okay, that's what's going to look like your tables. Okay, without the numbers. Let me see if I can get the numbers here. Spreadsheet, corrections, lab 01, group 1. Okay. Okay, so here you go. That's one of the tables. Okay, so you're going to copy each of those tables and paste there in your. I'm going to prepare a document that can be used for publication. Okay. There's a interesting. Okay, so you want to fit those tables properly here in the page. Let's see if I can get that. Okay. Suppose that you're publishing that, so you spend some time working on. That's not good. Let's see if I can make it smaller. Yeah, it's not gonna work. What I can do, I can separate this table. Interesting. So let's do it. Here you go. We're gonna start with this column here. Let's see if I can move this one. Yeah, now I can move it. Now, what about this one? I gotta do something about that. Moment. It's not deleting it. Strange. Huh. It's supposed to be. Okay, so no. Think section 9, you know? Yeah, there's 2 more columns here that didn't show up. And for some reason, it's not deleting it. I don't know why. Huh, interesting. Delete columns. Okay, now I did it. So I'm going to continue with those columns in the next line. Okay. I don't need that because it's the other experiment. You go. Okay, so copy those 2. Another way would be just to format this page in the horizontal direction. That would be another way. Okay, no, I don't like that. Huh. Completely off. You can do another thing too. There's another way of doing that. I'm gonna do this way. I'm gonna do the other way so I don't struggle here. You can also snipping tool, copy and paste there as a picture. Okay, here you go. Now you can also turn this page sideways 90 degrees. If you want to make this one was negative, shouldn't be negative. Oh yeah, this one is negative. I see. Yeah. Let me get this guy shrink a little bit. I'm gonna shrink this one a little bit. Yeah, I'm gonna brief you exactly how this experiment is performed. Okay, but every lab report, you'll be doing something like that. Okay, now I can get a better table. Here you go. That's one way. The other way is just to copy and paste the actual table, like I was doing. Make the table as large as you can, okay, so you can see it. And then there are other tables there as well, not just this one, right? This one, this table, okay. Make sure every number appears. Okay, so that what this syllabus is telling you. Next page, prepare a table with the original data and any results. The table must be neat and well planned. Graphs, if any, okay? So you're gonna copy those graphs and paste. No, those are the tables. Let's see if I can get the graphs. I'm not pasting every table, okay? Here you go. That's one of the graphs. But you notice that it didn't show up everything, right? Why is that? Because I failed to copy those lines. Those are things that you must be aware of, okay? You gotta copy everything in there. Let me paste it back. Or even better, you can go in snipping tool. I like to use the snipping tool. Okay, here you go. Copy the whole table. I didn't copy the whole table. Let's try it again. Note, see that this group put unnecessary decimal points here, right? There's no need to put all those 2 decimal places here. Copy. and paste. Here you go. And then there is another graph there as well. Graphs. Okay, copy. Again, there is unnecessary zeros here, okay? There are all sorts of unnecessary zeros as well, and we see that your equation is encroaching into the data, right? Be aware of that. Move it. Let me copy it again, so you can look, the graph can look better. Here you go. Paste, right? You know, don't get the thing, don't let the thing appear in there. What's next? Graph it. Any error analysis, if required, provide a percentage difference between your results and the expected values. Usually this error analysis is in the tables. Answers to any question, that there won't be any answer to the question, okay? So you don't have to worry about that. This is the so-called, this document is the so-called hard copy, part of the lab report, which must be labeled as, P07, right? Lab number, group number, and upload to your group folder. Okay, so that's what I want to cover here for the lab, and take a look again at the schedule, okay? And any questions? It's 11:40 right now. So let's see, we have 20 more minutes to go. What I want to do, so, you know, just think about that. This electricity and magnetism, I would say, is the most difficult part of physics. Okay, it's not easy. It's not easy because it deals with very abstract concepts, things that you cannot see easily, cannot readily see. Okay, you have to imagine in your head that there's something, this property of electric charge, and those electric charges are usually microscopic in nature. You cannot actually see it with the naked eye, even though there are macroscopic objects that can be electrically charged. Okay, but that's what you have to do in this course. You have to exercise your imagination, exercise of your imagination to see what is invisible. Okay, what I want to do is walk you through this formula and how it works. Okay, so I didn't do that last time because we ran out of time, and let me get that download spreadsheet. We go 23 right in here. Physics 07. Okay, that's what I want here. I'm gonna turn off this grid line so we can look better. So those slides can look better, right? Okay, so here you go. Here's my electric charge. Negative electric charge can be represented by a point with a negative sign there, not a point, but in this case it's a circle, but this charge is supposed to be a point charge. Is my positive charge. Is my neutral charge. This one can be your electron, this one can be your proton, this one can be your neutron, okay? Okay, so two electric charges, they do exert forces between each other. This notation that you see here, you have the charge 1 and the charge 2, okay? Don't forget that forces is vectorial. Force is a vectorial quantity, right? That's why I put an arrow there at the top. What do you have here? You know, I'm gonna do even better than that. Here you go. I'm gonna do it by steps right now. I'm going to isolate the charge number 1 as though charge number 2 is even better. I'm going to put charge number 1 and charge number 2 next to each other, like that. Okay? And I want to find out what are the forces that act in charge number 1 alone, just like we are doing our free body diagram that we did in mechanics, right? And when I do that, when I do the free body diagram, what else I'm going to do? I'm going to make the other charge look like as though it is a ghost. Let me see if I can get that. Yeah, I can do that. Here you go. Oh yeah, here you go. Here's my ghost charge. Why is that? Because I'm doing the free body diagram of this charge alone. And when we do the free body diagram of this charge alone, what else do? We draw a rectangle around this charge. Okay, and the fill is going to be no fill. Okay, here you go. We also put some dashed lines just for you to understand that this is a free body diagram. And we have this force that the charge number 2 is acting on the charge number 1. That's the electric force. Okay, that's what the notation is all about. Force of 2 in 1. That's what this notation means. Force of charge number 2 applied to charge number 1. Make sense? Okay. And we can do the same for charge number 2. I can take out, I want to concentrate only on the forces applied to charge number 2. I'm going to make this charge number 1 looks like a ghost. Because why? Because I am concentrating only on the free body diagram of the charge number 2. And just like before, I came up with that notation, a similar notation that I had before. Force of charge number 1, apply it to charge number 2, right? The first number is the source of the force. The second number is which one is being, which the one is subjected to the force. Okay. Then if you have the whole thing, you can have all the 2 forces right in there. According to Newton's third law of motion, those 2 objects are interacting with one another. Because they are interacting with one another, their forces are going to have the same magnitude but opposite direction, right? That's what Newton's third law is all about. So the magnitude of this force here, the length of this force here is going to be the same as the length of the other force. Let's see if I drew it correctly. Here you go. Let's see if I drew it correctly. Yeah, looks like I did, right? They have, both arrows have the same length. If they don't have the same length, they have almost the same length. Okay. The same thing for charges of the same signs. Okay. The same thing. Well, they repel each other, right? But we also can go through the same treatment, right? Come up with the free body diagram for each of those separately. Okay. And here you go. Here's my notation. Force of charge I on charge J, Fij. Okay. Now we have charge 1, charge 2. We have this distance between them. And now, okay, that's a vector distance from one charge to another, vector position, vector that goes from charge 1 to charge 2. Okay. And we have force of 1 in 2, force of 2 in 1. Okay, here's my unit vector, R12. And here's my other vector, R21, that goes from charge 2 to charge 1, vector position from 2 to 1. Why am I doing that? Well, because there is an equation in, let me see if I have it here. We have an equation of the force in terms of vectorial format. It is right in here. Let me get that for you. P07. Oh yeah, right in here. Okay. You can go either way. You can write down in terms of the vector notation, or you can write down in terms of the scalar notation, but don't forget that like charges repel, right? And opposite charges attract. The vector notation tells everything about that. Let's test this formula. That's how is the actual vectorial formula for this force. Okay, so here you go. I'm going to put aside. Okay, let's test. Let us test. Let us test the above vectorial equation. Okay. Say that Q1 is greater than 0 and Q2 is less than 0. Okay. You already know from the other type of treatment that this force is going to be attractive. Okay, so here we go. I'm gonna put it here so it looks nice. Okay. Force of 1 applied to 2, right? So let's go ahead. Go. Let's see how it looks like there in my slide, in my PowerPoint slide. Okay, so here we go. Let's see. Force, I want force of 1 and 2, right? Force, that's force of 2. Okay, we're gonna work with this one here. We're gonna work with this one here. I'm gonna do a movie, right? Start with charge 1 and charge 2. What time is that? 11:40, 49. Okay, let's do this. Let's leave this way, right? Okay, since Q1 is positive and Q2 is negative, it means that Q2 times Q1 is going to be negative, right? So this number is positive. This number is the square of a scalar. It must be positive as well. Scalar is a real number. Okay. R12 is from the left to the right, going from the charge number 1 to charge number 2. What you see here is the unit vector. Because Q1 times Q2 is negative, it means that F12 must point in the opposite direction of R12 hat. Make sense? Okay. So now let's do the other way. Say that Q1 is positive and Q2 is positive. That implies that Q1 times Q2 is positive, right? Let's see if this equation works. Okay, should be a slide with charge positive. Let's see if I have it here. Yeah, I have to do that from scratch. No, I don't need to do it from scratch. Okay, here you go. I have this one right in here. Okay, I have this one right in here. Okay. Q1 times Q2 is positive, right? So is the force of 1 in 2, this one right here, right? That's the vector position going from 1 to 2. Vector position going from 1 to 2. Here we go. Let me put some grid lines there. Yeah, my vector is completely crooked, right? Here you go. Can you see that? Here you go. From the center of charge 1 to the center of the charge 2. Okay. Consequently, the hat vector I12 hat is gonna also point in the towards the right direction. Let me see if I can do that. No, that's not what it is. No, it's like that hat. Yeah, good, worked. That's exactly what I want. Now I gotta get rid of this vector sign. Yeah. Sometimes this software doesn't work in the way it's supposed to work. Oops. Let's see. No, I got a copy from somewhere else. Let me copy from here. Otherwise, I'm gonna keep on struggling. Or even better, I'm gonna copy from here. I'm gonna copy from yeah, this one here. I wanna copy, so I don't have to keep on struggling like that. Yeah, here you go. Now I have it. I don't need that anymore, right? The only thing that I have to do is to make sure that this guy has everything is black. Yeah. Okay. Remember, the force of 1 in 2 is supposed to go to the right. Okay. Why I don't have it here? Yeah, here you go. Let me copy that. So that formula works. Okay. The force of 1 in 2 is going to be parallel to the r hat 1, 2. 1154. What else can we talk about? I think we can stop right now. So keep that in mind. Keep in mind those two notations. Okay, I want you to get familiar with this vector equation. I will, there will be a question in the exam about this vectorial equation. Also, I want you to learn how to operate with it. Okay. And 1155. What else can we do here? Here you go. Here's a characteristic of the electric charge. The electric charge is quantized. Okay, every charge value that I'm going to see out there is going to be an integer number of that value. That's 1e, 2e, 3e, 100e, 1000e, etc. Okay, you're not going to find half e, 1.5e. You don't find that. That's what the quantization of charge is all about. And I guess we can stop here, and I'm going to erase that. I'll see you again on Monday, right? And don't forget, I have office hours right now. If you want to talk with me, I'll be here. Let's see, there's a chat message. Someone sent me a chat. When you upload the video. Oh yeah, I'll be uploading this weekend. Yes, I will upload this note to Canvas. And I'll be doing that this weekend. And don't forget, yeah. Let me see. Yeah, that's right. I'll be uploading the videos. Yeah, go ahead.
I was wondering, I don't know if someone asked this question about the lectures, but I was wondering if, or like how soon after our lecture will the recordings be uploaded? I'm sorry.
In the weekend. Okay, I have a video on Monday. I have this video. Let me stop the video before I forget. Stop recording. Okay, I show you.